Hey guys, I'm going to be doing a question. I don't actually have the question on here, I just have the periodic table, so I'm going to go off that. So the question is, it's number 119 in chapter 7 of the Zundel textbook. The question is, okay, the electron affinities of the elements from aluminum to chlorine are negative 44, negative 120, negative 74, negative 200.4, and negative 384.7 kilojoules per mole, respectively. Rationalize the values, the trend in these values, okay? They're telling us aluminum to chlorine, and they're telling us respectively, which means all the numbers they gave, the numbers follow each element respectively, so in that order. So they start by telling us negative 44, negative 120, they tell us negative 74, negative 74, negative 200.4, and they also tell us negative 384.7. So then the question asks, rationalize the trend in these values. Okay, so based on, when we look at this, based on the fact that there's an increasing nuclear charge, like the charge is increasing as we go up, right? Because just think about it, okay? 7 minus 6, you get it, okay? Valence electrons, sorry, okay. We're gonna expect the electron affinity values to increase and to become more exothermic as we're moving from the left to the right? So phosphorus obviously is, you can see out of line, one of the exceptions, but we know that this is one of the, we know that electron affinity is erratic, so we don't expect everything to always be perfect, right? So when you think about this, like when you're trying to rationalize the way that phosphorus acts, this is sort of how you have to think. When you have the phosphorus gas and you're adding an electron, you're making phosphorus gas with a charge of -1, right? Which changes the whole electron configuration from originally 3s to 3p3. And then for here, this is why 3s2, 3p4. What happens is this is now not 3 unfilled electrons. This is now only 2, right? 4 means you need 2 more to be paired. This is why the change in the phosphorus does not really coincide with everything here. But I want you guys to kind of think about something. Generally speaking, it does make sense that the ionization energies are increasing, because you have to think about it like this. As you're moving from left to right, the atomic radius, hold on, I'm trying to zoom in, but for some reason it keeps freezing. Let me see if I can pull it up on here. No, for some reason I can't. Okay. So, atomic radius. I think this is actually written wrong. Give me a minute. This should be decreases. Okay. So that means atomic radius. Okay, so the atomic radius is decreasing, right? The atom is getting smaller. Obviously, this is relatively smaller, right? Which means that there's less electrons floating in clouds, which means that the electrons that are there are very tight and very bound to the nucleus, which means that it's going to take more energy to remove these electrons. The reason that phosphorus is an exception is because instead of it now being 3 floating, it's going to be a pair and 2 floating, which makes these less bound, which makes it take less energy. Okay. So that is how sort of like the exceptions work, if you were wondering.